Today we're again going to look at taking derivatives of things that can't just easily follow other derivative rules. So far we've learned how to take derivatives with basic rules. We've learned how to take derivatives where the y isn't by itself. And now we're going to learn how to take the derivative of the inverse of a function. So let's start by reviewing what the heck an inverse function is. An inverse function is a function that takes all of the outputs of the original function and gives the inputs. For example, find the inverse of this function, then make a table of values for both the original and the inverse. When we learned how to find an inverse back in pre-calculus, we said in order to do this, you're just going to switch the x and the y. So I would have x equals 4y cubed minus 1. And then solve for the y again. So I would add 1. I would divide by 4. And then I would cube root it. And this would be the inverse function. Now let's make two different tables of values. This is going to be the table of values for the original. So let's look at the original function. I'm going to pick some x's, just kind of randomly. I should probably move this so you can actually see what I'm doing. I'm going to pick some x's kind of randomly, so -2, -1, 0, 1, and 2. If I take a -2 and I plug it in here, I get -8 times 4 is -32 minus 1 is -33. Now I'm going to take a -1 and I'm going to plug it in here. -1 cubed is -1 times 4 is -4 minus 1 is -5. Plug in a 0, I get -1. Plug in a 1, I get 4 minus 1 is 3. And plug in a 2, I get 8 times 4 is 32 minus 1 is 31. Now let's make a table of values for the inverse. So I'm going to be plugging numbers into here. Now this isn't a particularly nice function. A lot of numbers that I plug in here are going to be weird decimals. So watch what I can do. Take the original y's and make them your new x's. Now plug those in. -33 plus 1 is -32. Divided by 4 is -8. The cube root would be -2. -5 plus 1 is -4. Divided by 4 is -1. Cube root is -1. -1 plus 1 is 0. Divided by 4 is 0. The cube root is 0. 3 plus 1 is 4. Divided by 4 is 1. The cube root is 1. 31 plus 1 is 32. Divided by 4 is 8. The cube root is 2. Do you notice that all that the inverse did was it switched the x and y values from the original? It takes your outputs from the original, and when you plug them in, it gives you back the inputs from the original. Now that's going to be really important for a second, is understanding that when we're talking about an inverse, the inputs are the old outputs and the outputs are the old inputs. So it's really important to understand that. Let's look at some derivatives now. Just like for implicit differentiation, there's a process that we follow for finding these derivatives. It's not about memorizing a formula. It's about following a process. The technical formula is this, which looks super complicated. So let's break it down. This means inverse. And then this means derivative. So take the derivative of the inverse function. Now you'll notice here that the y value of the original is the number that we are plugging in. And the reason that this is a y is because the inverse, you plug in the y's. Now here's how you actually calculate this. To get the derivative of the inverse at this y value, you do 1 over the derivative of the original at the corresponding x value. So we really are going to do this process in 3 steps. First, we're going to take the derivative of the original function because we know we need the derivative of the original. Then we're going to write 1 over the derivative of the original function. Then we're going to use the given y value. They're going to give us this y value in the directions. Find this thing. To calculate and plug in the corresponding x value. So you're not going to know this number that you're plugging in right away. You're going to have to calculate it, and that's going to give you your final answer. It's 3 steps. Derivative, 1 over the derivative, calculate the x and plug it in. Let's do this step by step. It says, let's let the original be this guy. Find the derivative of the inverse at this y value. So let's see. First, we know we need the derivative of the original. Now be very precise with your notation here. This is the derivative of the original. So I would get 5x to the 4th plus 1. Then, the derivative of the inverse at this y value is equal to 1 over this guy, which has an x in it. Again, the derivative of the inverse has a y. This has an x. That is your clue that you can't just plug in this 1. This is a y, this is an x. So your third step here is to say, okay, if this is a y, let's find the x. So let's let our original function equal 1, because that's the y value. And let's solve. If we subtract 1 on both sides, we get x to the 5th plus x equals 0. So if we factor out x, we get x to the 4th plus 1 equals 0. So we get x equals 0. X to the 4th plus 1 will never equal 0 because x to the 4th is positive, so if I add 1, it's never going to give you a 0. So this would be the corresponding x value, which means the second part of the third step after you calculate that number is to actually plug that in. So the inverse function's derivative at the number 1 is 1 over the original function's derivative at 0. Which means the inverse function's derivative at 1 will just be 1. Okay, 3 steps. Derivative of the original. 1 over the derivative of the original. 1 over that function. Calculate your x by saying if this is a y, let's calculate, plug in that x. Let's try it again. First, we're going to take the derivative of the original. Then we're going to say, okay, the inverse function's derivative at the y value is 1 over the derivative at the x value. Now in this problem, it doesn't really have an x in it. So we don't really have to calculate an x because there's nothing to plug in. So my third step would just be to say that the derivative of the inverse at -1 would be a half because there is nothing to calculate. The formula doesn't have an x in it. Let's try it again. First, we would find the derivative of the original. Then we would say the inverse function's derivative at the y value, because inverses take in y's, would be 1 over 3x squared, where this has an x. So this is a y, which means we need to calculate the x that we're going to use. So we would make x cubed minus 1 equal to 7. When you solve this, you would get x cubed equals 8, so x equals 2. Now that I know that x has to be 2, I just plug it into this formula. So the inverse function's derivative at 7 is equal to 1 over 3 times the corresponding x gets plugged in squared, which means the inverse function's derivative at 7 would be 1 over 12. Last but not least, let's try one more. So first we would take the derivative of the original. Now this is really like having negative x minus 2 to the 1/3 power. So I'm going to use power rule. I'm going to have 1/3 negative x minus 2 to the negative 2/3. Now I'm going to choose to rewrite that as 1 over 3 times the cube root of negative x minus 2 squared. Now my second step, the inverse function's derivative at the y value would be 1 over this stuff that I just wrote down over here. Now here's the thing though, 1 divided by this stuff is really just the reciprocal. So the function would really just be this. Basically, when you do this, when you do 1 over this stuff, it's just the reciprocal. So we're just taking this and flipping it over. Now we need to calculate. So if this is a y value, let's make our function equal to that y value. The cube root of negative x minus 2 equals 1. Now I would cube both sides, so negative x minus 2 equals 1. I would add 2, so negative x equals 3. And then I would divide, so I would get negative 3. This now is my x value. So I'm going to plug that in. So the inverse function's derivative at 1 would be plugging in this x. So negative 3 minus 2 would be negative 5. Squared is 25. 3 cube roots of 25. Oops, sorry, it'd be positive 3 minus 1. 3 minus 1 is 1, squared is 1. So this is a 1. Oops, sorry. My bad. Which means we can actually simplify further. I can do math. It would just be cube root of 1 is 1, so 3. And then that's it. Okay. We're going to talk a lot more about this in class tomorrow. We will do a lot more practice, but I want you just to remember it's 3 steps. OG derivative, 1 divided by the OG derivative, which is just the reciprocal. Calculate your x and plug it in. And then that's the end.